In this video we'll be talking about random variables. Random variable. We'll use this abbreviation occasionally. Definition. A numerical variable whose value depends on the outcome of a chance experiment. Discrete random variable. A random variable with possible values that are isolated points on a number line. Continuous random variable. UOUS, continuous random variable. A random variable with possible values that are all points in some interval. All points in some interval. Typically, we're going to see this discrete random variable as being something finite, and this continuous random variable as being an infinite number, a portion of the number line. All right, let's look at a couple of specific examples. Example. Number 1. We're going to let x equal the number of boys that a couple will have if they plan on having 3 children. So what we see is this x is the random variable. It is a numerical variable. That is, it's a variable. It's some symbol representing an unknown. All right, but it's going to represent a number whose value depends on the outcome of a chance experiment. So we can have, you could think that x in this case, x could, in math we use this term element of, x could be in the set 0, 1, 2, or 3. These are the possible outcomes. If we're having 3 kids, we could have no boys, 1 boy, 2 boy, or 3 boys. And these are distinct points on the number line. All right. Number 2. This situation is discrete here. Number 1 is discrete. All right, number 2. Let's let x equal the time it takes me to complete this video. Well, you hope that that's not too long. So this number 2, this is continuous. Okay, continuous. That is, while we hope that it has some endpoint, perhaps obviously it's going to be greater than 0 minutes. Maybe 30 minutes is the outside length of time this could be. But it could be anywhere in here from 0 to 30, and theoretically that's an infinite number of possibilities. Maybe this right here would be 10.37, and maybe this over here would be 27.465 minutes, and there are an infinite number of values on this number line between 0 and 30. So while this video hopefully is not infinitely long, there are an infinite number of outcomes depending on possibly the sensitivity of my measuring stick. So you get the idea. Discrete means it's specific values on the number line, and often we think of them as being integers. And continuous is some interval of the number line where it can have an infinite number of outcomes. All right, the remainder of this video will focus on this discrete case. Okay, PDF. PDF stands for probability. Distribution. Function. And function, just like in algebra, a function is just a pairing. It's how some x's get to some y's, how some inputs get to some outputs. In this case, the inputs are going to be these values that our random variable takes on, and the output's going to be some probability. A probability distribution function gives a probability that's going to be my output for each outcome. Okay, and those are my inputs, the 0, 1, 2, 3. All right. In algebra, this function in algebra, we often think of it as a table. You know, we'll have some x and some y, and they'll give us some x's and they'll map to a y. Well, instead of using y, often we use function notation in algebra. We use this this notation f of x. All right. This is my input, this is my output. Well, we're going to do a similar thing in statistics. We have to be a little bit different, obviously. All right, we're going to write our table. Oftentimes, you'll see it displayed horizontally. Here will be the x, my input, and down here will be my f of x, but we're going to call it p of x. This symbol outside, it's arbitrary. We could make this H, A, B. You can make it Bob, smiley face, whatever symbol you want to. In algebra, they choose F frequently for the word function. Here in statistics, we're going to choose P almost exclusively for probability. So this is X, my outcome. This is the probability associated with that X. So let's refer back to my definition here above. Let's let x be the number of boys. So I'm going to say x is equal to, as above with the boys, x is the number of boys a couple will have if they plan on having 3. Well, we've already decided, well, you can have 0, You can have one boy, you can have two boys, you can have three boys. Those are the outcomes. Now what we're going to be interested in is finding these associated probabilities. All right, I'm coming over here to my scratch paper, and let's consider how many ways that this thing could come out. You can add this to your notes or not. Well, we're having 3 kids, right? 1, 2, 3. This is called the multiplication principle. The first kid can be a boy or a girl. The second kid can be a boy or a girl. The third kid can be a boy or a girl. So I can multiply these numbers together and tell you there will be 8 possible outcomes. All right? Let's look at how they could come down. It could be boy, boy, boy. It could be boy, boy, girl. Okay, and you can probably see where we're headed with this. It could be boy, girl, boy. It could be boy, girl, girl. Look at the pattern that's happening here. B, G, B, G. Now here, B, B, G, G. You can guess these next two are going to be B's. B, B. And this thing will keep with this B, G, B, G pattern. B, G. All right. Here we've had the boys first. Well, the rest of these are going to be the girls first. Girl, 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 girl. All right. So what's this going to be? Well, we're B, B, G, G, B, B, G, G. And BG, 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 this will be BG. So we see these are all the outcomes. You can have 3 boys. You can have the first 2 boys, then a girl. Boy, girl, boy. Boy, girl, girl. All the way down to girl, girl, girl. And there's 8 outcomes here. 1, 2, 3, 4, 5, 6, 7, 8. So to fill in this table, we just need to see what's going on. This is saying 0 boys. Well, that's just this one right here. This is the only 0 boy outcome. All right. So the chance of getting all 3 girls is 1 out of 8. That is 0 boys. Okay. Well, not coincidentally, that's going to be also the chance of getting 3 boys, because if you get 0 girls, that's the same. To get all girls is the same as getting all boys. So the chance of getting 3 boys here is 1 out of 8. All right. Now we want to look at the chance for 1 boy. 1 boy. That ain't getting it. Nope. Nope. That's 2 boys. Here's 1 boy. That's 1 boy. 2 boys. There's 1 boy. And there's 1 boy. So we see 3 out of our total 8. The chance of getting 1 boy is 3 out of 8. Okay. So what's going to be the chance of getting 2 boys? It's going to be that same 3 out of 8, because getting 1 boy would be the same as getting 1 girl. And if I got 1 girl, then that would be 2 boys. Let's look at it. Here's 2 boys. Here's 2 boys. And there's 2 boys. So we see 3 out of the 8 times there will be 2 boys. All right. Couple notes. 1, these numbers will always sum to 1. These are all my possible outcomes, and you'll see that 1/3 and 3/3, 4/3, 7/3, 1/8 and 3/8 is 4/8, 7/8 and 8/8. These are my total possible outcomes. So now I can look at this distribution and begin to answer some questions. One important question is what's going to be called the mean of this random variable. Mean of a discrete RV. All right. And we're going to use, we also call this the expected value. Expected value. Okay. We use a couple of different symbologies here. Sometimes you'll see it written as E of x, the expected value of this random variable x. Frequently you will see it as mu. This is our symbol for the population mean, mu of x, the average of our random variable x. Well, this is simply going to be equal to the sum of each one of our x's, x sub I, times the probability associated with that. Okay. Now this looks a little bit crazy, but when you see this example, it's going to make perfect sense. So for our random variable x here, here's what I would say. The mean of our random variable x is going to equal each x times its probability. So we'll take 0 times this 1/8. 0 times 1/8. Alright. Then we will add to that 1 times 3/8. I'm just taking the number and multiplying it by its associated probability. Okay. Plus 2 times 3/8. 2 times 3/8. 3 times 3/8. 3 times 1/8, pardon me. 3 times 1/8. Alright. Now I'm just going to sum these up. That's 0. That's 3/8. 2 times 3/8 is 6/8. 3 times 1/8 is another 3/8. Alright. And if you add all these up, that's 9. And 12 over 8, and 12 over 8 is 1.5. 1.5. What is this 1.5? It's 1.5 boys. Now, I know what you're thinking. We cannot possibly have 1.5 boys. That is true. But that is not what this mean of the discrete random variable means. What you must keep in mind is our frequentist interpretation of probability. Okay? And it is this. It is in the long run. Okay? In the long run. Our long run average. The average number of boys a couple with 3 kids will have is 1.5. Will there ever be a time that you have 1.5 boys? No. Sometimes you're going to have 0. Sometimes you're going to have 1. Sometimes you're going to have 2. Sometimes you're going to have 3. But if we took all of those couples that had 3 kids and added up their number of sons and divided by the number of people there, it's going to be 1.5. And that makes perfect sense because half the time you're going to have boys and half the time you're going to have girls. If you're having 3 kids, 1.5 will be your long run average. That is how many boys. If we, again, no couple is going to have 1.5 boys, but our long run average, our expected value of this random variable is 1.5. All right, with this information, you should be able to handle the first couple of parts of this assignment.